week was a disaster. I didn't get enough subscribers. I need to get more views and I need to get more subscribers. I gotta beat Logan Paul. I mean, my name's Aaron Paul. Logan Paul's going down. PewDiePie, this is Fleming Pie. I gotta have more subscribers. What do you think we can do?
I think you have to look better.
Me look better? Is that possible?
Yeah, of course it is.
Okay, well,
It'll make you look better.
do your magic. Do your magic.
Okay?
Yeah, do your magic, guys.
Brush your teeth first.
Oh, brushing your teeth. That's a good idea.
Brushing your hair.
Oh, brushing my hair. I thought I just had to put that thing on. Okay. Yeah, that should be good. That's got the first thing up there, I think. Okay.
Yep.
Okay, what else?
Teeth are alright.
What else do you think?
This will do. This will do too.
Oh, yes. Oh, that feels much better. Okay. Yeah, yeah. We'll get the stuff off the shoulders there. Yeah, thanks.
Okay.
Thanks. Yeah. Oh, okay, good. Is that looking good?
Yep.
Oh, I'm okay?
Fantastic.
Okay, good. Five, thanks.
Very good.
Good. Whoa. Yeah. Let's do this. Let's get this videos done. Hello, and welcome to this video where I'm just going to explain a little bit about the Arduino board and how we're going to wire it up here. So obviously the main components, just sort of run through those quickly here, is the Arduino board. As I mentioned, you can pick one of these up for $10, $15 usually, they look a little bit complex, but the big idea is that you've got your USB, okay, which you can plug in right here. This one here is for an external power supply, so you don't have to run it connected to the computer. You can. A USB supplies 5 volts of power, plus obviously the data connection as well when you want to upload, which we'll get to a little bit later. And then also the, so you could run it separately, but you obviously need the power supply, so a little battery pack or whatever you could attach there. We'll run it just off the computer. Well, you're going to run it virtually anyways, but we would do that in class. Now, if we look at these 2 rows here, these are the important things. These are sort of the connections where we can plug in our jumper cables or jumper wires, which are these little guys here, and you'll do that virtually. Basically along this left side, and if you look sort of closely, and it's a little hard to see, and you can see it better possibly when you are doing the simulation, it says 5 volts, like RES, resume 3.3 volts, 5 volts, GND for ground, VN, voltage in, and then there's these A0s to A5. These are pins relating to analog 0 to 5. We'll talk more about those later. On the right side, so down here, you've got this RX, TX, don't worry too much about that, but 0, 1, and then it says digital pins, as you can see, and they work all your way up to 13, so it's from 0 to 13. Generally, we don't want to use 0 and 1, though, so really sort of up from 2 to 13, and then starting to the top, there's another ground, and then I'm not 100% sure what these guys are up here, but yeah, that's the basic layout. Little button, reset button there, okay? So that's your Arduino board. This, somewhere in here, this guy, I guess, that's where all the processing goes, maybe in this guy as well. There are little computers, and you can kind of see all the tracings, and those are the electrical connections between them. So you can see this sort of coming out of the pins and going into this chip here, and along the back there too. They're pretty robust. I mean, you can drop them and they're not going to break, but obviously you want to sort of keep your fingers off this area if you can. Inside here, and we'll see that in a couple minutes, there's lights that blink and give you some idea of what's going on. Most Arduinos look like this, but Arduinos are open source, which means basically you could go ahead and make your own Arduino, and therefore to ease manufacturing, to whatever sort of specifications you want, you can modify and make it your own kind of thing. So yeah, there are some variations, but that's the basic layout. Now, a couple other components that we're going to have to use, and sort of a staple of any electronics, and if you've done electronics, you'll have seen this guy before. This is called a breadboard. And you can see there's just a bunch of holes. There's a plus and a minus, and then A, B, C, D across the top, and then 1, 2, 3 up down to 30 here. They come in various sizes. This is kind of a smaller one, good for our purposes, but you can get bigger ones or even really small ones if you need it. Now, It's a little bit tricky, and I'll probably pop up on the video here a diagram that will explain it better, because I don't really want to break it apart. But just to give you an idea, so down this channel, okay, these sort of vertical columns here, the plus and the minus, and they're on the other side as well. They are all connected. So from this top one here for the plus, all the way down to the bottom one of the plus, they are connected. And then same thing with the negative to the negative here. So if you put something, you've got current or whatever flowing through here, it's accessible all the way down here. Okay. Now the plus and minus, there's nothing special about them. They're just labeled plus and minus, so positive and negative. And that's just if you want to, right? If you want to use it as positive, that's generally the way you want to run it. You don't want to, confuse people by having the negative and the positive and the positive and the negative. Now across, and that goes on the right side there too. Now down the middle is this sort of trough here, and that sort of indicates that these two sides are separate. Now if I looked here, sort of like A1 or 1A, all of 1 are connected together. So again, if you put sort of current in here, the current's available anywhere from A through to E. Okay, but that current doesn't flow unless you connect it to F. Okay, so the current sort of stops at this gap, and then it sort of, if you plugged in a positive current going through here, the positive would be available, the 5 volts or whatever would be available up to here as well. So, and then sort of going down, each of these is separate. Okay, so like 1 is not connected to 2, but 1A is connected to 1E. Okay, or 1F is connected to 1J. Okay, so try to keep that in mind. It will make more sense when we set things up here. So a few other components. Like I said, this is just sort of a talk about the components here. These little jumper wires, they're designed just to make it easy to plug in. Okay, so they can simply go into one of these slots. It'll take a little bit of force once in a while, but they generally just sort of pop in there, and they're making that sort of a tight electrical connection there. Okay. Another little thing that I've got here that we'll use, resistors. I don't know if you've done it in science. I remember doing science. I remember teaching it in science. These little color banding here gives you the idea of how much resistance there is. Don't worry about it too much. But if you were building a specific circuit, you might have to worry about the resistor. You need a proper size resistor. They don't write the number on it. You have to figure it out by that colored banding. But the idea is that, again, this could plug into your board. Okay, it's flexible, right? These are flexible wires. Obviously, over time they might snap. One interesting thing is they don't have a positive or a negative end, nor do these wires, right? I mean, I could plug it in, this one into the positive and this into the negative, sort of into and vice versa. It doesn't matter. Current will flow through either direction. Same thing with a resistor. So a resistor, its purpose is really to slow the current down. It puts in resistance. So when the electrons are sort of passing through, and we can think of it that way, they are getting slowed down. So this prevents sort of current from just running amok, basically, causing sort of a short circuit where it would just burn things up. This will slow it down. It will slow it down. Obviously, there's energy in that movement of the electrons. It slows it down by generating heat. So your resistors can actually get pretty warm if you have if you've got a lot of current going through them. Okay, but that's their purpose. Slow the current down. Again, it doesn't matter if it's positive or negative. And just like before, I could just slot it in. Again, it takes a little bit to push it down. Especially these wires are a little flimsy, and then they just go in there. Okay? And the nice thing about the breadboard, I didn't really explain why we use a breadboard, is that I can reconfigure it, constantly. I mean, they will wear out at a certain point, but I could do hundreds of different variations, and I don't have to worry about soldering and making something permanent. So it just makes it really easy to create circuits and play around. And then when you were sort of going to finalize it, then you could do your soldering or whatever. Now the last component that we'll need for the first couple of weeks at least is an LED light. And now these LEDs, these are very simple ones. They're one color. Some of them will be white, some of them will be whatever color. The LED itself could have a different color. Some of them are colored. Okay, so this one is probably just a white one, but it's got a just a blue sort of coating on it. interesting enough, you know, LEDs have become a lot cheaper over time. LEDs used to be very expensive, and in fact, it was hard to get nice white LEDs. Again, you can pick up probably like 500 or 1,000 for 10 bucks of these LEDs. Now, these are a little bit different. So LED stands for light emitting diode. So it is what's called a diode, and we don't have to worry too much about that. But one interesting property of a diode is it only lets current run in one way. So if I look at this, there's a couple ways to tell which way the currents, or which is the positive side and which one's the negative side. The easiest way, and the way I generally do it, I'll tell you what the problem with it in a second, but is that the longer side is the plus. So I always think of, okay, if the plus, right, it's a plus like that. If I extend those two lines out, it's longer than just a negative. So that's the way I always remember. Plus is the longer one, because if I put those two ends of the plus sort of together, they make a longer line. So your positive is going to be the longer one, and the shorter one here is your negative, okay? So the orientation does matter. If you put this in the wrong way, as opposed to, say, the resistors and the wires, which didn't matter, then you're going to run into an issue where it won't light up because the current won't pass through. So a diode will only let the current pass through in one direction. So basically, the positive has to be on the positive side, and then the negative on the negative. And we'll get to that. The other, I was just going to mention, there is one other way. I can hardly ever see it. I don't know if it's just me getting old. One side, and you can kind of hopefully see it there, is flat. The flat side is the negative. Okay, so the flat side versus the sort of rounded side, and again, you probably almost have to have an LED in your hand to sort of see that. I don't know if that's more visible here in the blue. This one's smaller though. It has sort of a flattened end, whereas the other one has the rounded end. So I can almost feel it better than I can see it. Okay, I guess that's a factor of getting old. Anyways, those are the basic electrical components that we're going to use. There's hundreds, if not thousands of more that we could possibly use, but at least for the moment, setting up our light and then doing our basic little light show, we are going to use just these. I've got a collection of them here. All told, you know, this is probably, if it's $1 worth of stuff, it's mostly because of the breadboard. These electrical components here would probably be, you know, 50 cents or if not less. And so that's what I mentioned about the kit is a possibility if you're wanting to do more. Good. So we'll end this video here. The next video we're going to look at actually setting up the Arduino just to get a light going.